LangGraph's runtime execution is orchestrated through the Pregel class, which implements the Bulk Synchronous Parallel model to manage actors, Pregel node, instances, and their communication via channels. This core mechanism coordinates parallel actor execution, channel updates, and step-based synchronization to ensure deterministic graph processing. We're about to examine how Pregel initializes with configurable parameters for node management, channel specifications, and execution control, including stream modes, interruption points, and persistence mechanisms. The constructor reveals how LangGraph establishes the foundational components for graph execution while providing hooks for state management and runtime behavior customization.
Pregel. Self. Nodes. dict_str Pregel node builder. Channels. dict_str base channel managed value spec none. Auto-validate bool equals true. Stream mode equals values. Streameager bool equals false. Output channels SDR sequence SDR. Stream channels SDR sequence SDR none equals none. Interrupt after nodes all sequence SDR equals. Interrupt before nodes all sequence SDR equals. Input channels SDR sequence SDR. Step timeout float none equals none. Debug bool none equals none. Checkpointer equals none. Store base store none equals none. Cache base cache none equals none. Retry policy sequence retry policy equals. Cache policy none equals none. Context schema type context T none equals none. Config runnable config none equals none. Triggered nodes mapping SDR sequence SDR none equals none. Name SDR equals LangGraph. Deprecated quargs unpack deprecated quargs equals.
The Pregel class serves as the runtime manager for LangGraph applications, implementing the Bulk Synchronous Parallel model to coordinate execution between actors and channels. At its core, it takes a dictionary of nodes, Pregel nodes or node builders that represent the computational units, and a dictionary of channels that facilitate communication between them. The class provides fine-grained control over execution flow through parameters like interrupt after nodes and interrupt before nodes, which enable dynamic pausing of graph execution for human-in-the-loop patterns. Streaming behavior is configurable via stream mode, with options like values for full-state streaming or debug for comprehensive execution tracing. The architecture supports persistence and fault tolerance through the checkpointer parameter, allowing graph state to be saved and resumed using thread IDs. Performance optimizations include configurable retry policy and cache policy for handling node failures and caching results, respectively. The step timeout parameter enforces execution boundaries, while stream channels and output channels provide granular control over which data flows are exposed during streaming operations. This design balances flexibility with structure, enabling complex workflows while maintaining deterministic execution through the Pregel algorithm's phased approach. The inclusion of interrupt mechanisms and streaming modes reflects LangGraph's focus on interactive, real-time applications. By combining actor-based computation with channel-mediated communication, the Pregel class creates a framework where nodes can operate in parallel while maintaining synchronization through supersteps. The trade-off here is between parallelism and coordination overhead, with the Pregel model providing a structured approach to managing this complexity in distributed graph execution. Let's break it down.
Pregel
initializes a Pregel instance, which serves as the runtime manager for LangGraph applications. Pregel organizes execution into discrete steps following the Bulk Synchronous Parallel model, coordinating actors, Pregel nodes, and channels to process graph operations in a structured, parallel manner. This line sets up the core execution environment without specifying any particular graph structure or nodes yet.
Nodes. dict_str Pregel node builder.
Declares a dictionary named nodes that maps string keys to values of either Pregel node or node builder types. This establishes a collection where each entry represents a node in the graph, identified by a string key, and can be either a fully constructed Pregel node or a node builder used to create one. The dictionary serves as a registry or lookup table for graph nodes during execution.
Channels. dict_str base channel managed value spec, none.
Declares a parameter named channels that accepts either a dictionary mapping, strings to base channel, or managed value spec objects, or none. This parameter is likely used to configure communication channels between actors in a LangGraph application, where each channel defines how data flows between nodes in the graph. The dictionary structure suggests multiple named channels can be specified, with each channel having a specific type or configuration.
Auto-validate, bool equals true.
Declares a Boolean parameter named auto-validate with a default value of true. This parameter controls whether automatic validation should be enabled by default when not explicitly specified.
Stream mode equals values.
Sets the stream mode to values, configuring the graph to stream the full state value after each execution step. This parameter controls how real-time updates are surfaced during graph execution, with values mode providing complete state snapshots at each step rather than incremental updates or debug information.
Stream_eager, bool equals false.
Declares a Boolean parameter, stream_eager, with a default value of false. This parameter likely controls whether streaming operations should be performed eagerly immediately as data becomes available or lazily waiting for completion. The default false setting suggests lazy streaming behavior by default.
Stream channels. SDR sequence SDR, none equals none.
Declares a parameter named stream channels with a type hint indicating it can accept either a string, a sequence of strings, or none. The parameter is initialized with a default value of none, making it optional when the function is called. This suggests the parameter controls which channels will be streamed, with the flexibility to specify a single channel as a string, multiple channels as a sequence, or leave it unspecified.
Interrupt after nodes. All sequence SDR equals.
Declares a parameter, interrupt after nodes, with a type hint indicating it accepts either all nodes via all or a sequence of node name strings, defaulting to an empty tuple. This parameter likely controls which nodes should trigger an interrupt after execution, based on the provided context about interrupt after in LangGraph.
Interrupt before nodes. All sequence SDR equals.
Declares a parameter named interrupt before nodes with a type hint indicating it accepts either all nodes via all or a sequence of node name strings, defaulting to an empty tuple. This parameter likely controls which nodes should trigger an interrupt before their execution begins.
Step timeout. Float none equals none.
Declares an optional parameter, step timeout of type float, or none with a default value of none. This parameter likely controls the maximum duration allowed for a single step execution in a LangGraph workflow, where none indicates no timeout is enforced.
Debug. Bool none equals none.
Declares a parameter named debug with type annotation, bool none, and default value none. This parameter accepts either a Boolean value, true or false, or none, indicating it's an optional flag for controlling debug behavior in the function or class where it's defined.
Checkpointer. checkpointer equals none.
Declares a parameter named checkpointer of type checkpointer with a default value of none. This parameter allows passing a checkpointer instance to enable state persistence across graph executions, though no specific checkpointer is provided by default.
Store, base store none equals none.
Declares an optional parameter named store with type base store none, defaulting to none. This parameter can accept either a base store, instance, or none, indicating that providing a store is optional for whatever function or class this belongs to. The actual usage of this store isn't visible in this segment.
Cache, base cache none equals none.
Declares an optional parameter named cache with type base cache none that defaults to none. This parameter allows passing a cache instance or leaving it unset, enabling caching functionality when provided.
Retry policy. Retry policy sequence retry policy equals.
Declares a parameter named retry policy that accepts either a single retry policy object or a sequence of retry policy objects, with an empty tuple as the default value. This parameter allows configuring retry behavior for nodes in case of failures, where the empty tuple default indicates no retry policy is applied by default.
Cache policy. Cache policy none equals none.
Declares an optional parameter named cache policy with a type hint indicating it accepts either a cache policy object or none. This parameter defaults to none, meaning caching is disabled unless explicitly configured. The cache policy type suggests this controls caching behavior for nodes or tasks, but the specific caching mechanism isn't visible in this line.
Context schema. Type context T, none equals none.
Declares an optional parameter, context schema, typed as either a type annotation for context T or none, defaulting to none. This parameter appears to be used for type hinting or runtime validation of context objects in a LangGraph application, where context T would be a generic type representing the expected context structure. The none default suggests the schema is optional, and the system can operate without explicit context type validation.
Config. Runnable config none equals none.
Declares an optional parameter config of type runnable config with a default value of none. This parameter allows passing configuration options to control runtime behavior, such as checkpointing, interrupts, or streaming modes, when executing a LangGraph workflow. The none default means no special configuration is applied unless explicitly provided.
Triggered nodes. Mapping SDR, sequence SDR, none equals none.
Declares an optional parameter, triggered nodes, that maps string triggers to sequences of node names, initialized as none. This parameter defines which nodes should be activated when specific triggers occur in the graph execution.
Name. SDR equals LangGraph.
Declares a string variable named name and assigns it the value LangGraph, with explicit type annotation indicating it must be a string type. This creates a typed variable that will hold the name value for potential use in graph configuration or identification.
Deprecated quargs. Unpack deprecated quargs equals.
Creates an empty dictionary variable named deprecated quargs with type annotation unpack deprecated quargs, indicating it's designed to hold deprecated keyword arguments while enabling type checking warnings for those arguments. The empty dictionary serves as the default value for this parameter. The Pregel class orchestrates LangGraph's execution by combining actor-based computation with channel-mediated communication, following the Bulk Synchronous Parallel model. At its core, it manages Pregel nodes through the nodes dictionary and facilitates their communication via configurable channels. The architecture balances parallelism with coordination by organizing execution into discrete steps where nodes operate in parallel but synchronize through supersteps. Key control mechanisms like interrupt after nodes and interrupt before nodes enable dynamic execution, pausing for human-in-the-loop patterns, while streaming modes like stream mode and stream channels provide real-time visibility into graph state. The system supports persistence through checkpointer and fault tolerance via retry policy, with performance optimizations through caching controlled by cache policy. The design trade-off is evident in how it structures parallel execution while maintaining determinism through phased synchronization. What ties these components together is the Pregel algorithm's phased approach. Nodes execute in parallel during each step, but channel updates only become visible in subsequent steps. This creates a structured environment where complex workflows can be built while ensuring deterministic execution. The interrupt mechanisms and streaming capabilities reflect LangGraph's focus on interactive applications, allowing for both automated processing and human intervention when needed.
The checkpoint halts the graph, yet whispers to the nodes, "Keep running, the next snapshot awaits."